Hey guys, welcome to the second video for our flipped classroom. We're going to go ahead and get started. We are on page 10 today and we're talking about kind of a new topic. It's called arc length. And let me go ahead and define it for you before we run into some examples. But an arc length is basically, by definition, the same measure of an intercepted angle. So let me draw a picture for you. So if this is your unit circle, and let's say we're focusing on some angle in the first quadrant, and we're going to call, because we don't know what it is, we're going to call it theta. And as you all know, on the unit circle, our radius is typically 1. But here's what we're talking about since we are focusing now on arc length. So what that means is whatever angle you have, the length of the intercepted angle would be this right here, and we're going to call that S. So what we're focusing on is this piece right here that kind of looks like a slice of pizza or something, a slice of pie. And the way you find arc length is simply, and we do call it S. I know it kind of seems weird, but S equals theta in terms of radians. Remember that little r that looks like a power is actually, it's actually there for radians. We're going to use that formula only if our radius is 1. And as you remember, radius is only 1 when we are talking about the unit circle. But sometimes if you look down the page, you'll see a lot of our examples, actually most of them, do not have a radius of 1. So if that's the case, if we do not have a radius of 1, what we're going to have to do is tweak it a little bit, and we're going to say our arc length is now going to be our theta, our angle in terms of radians, times whatever our new radius is. So let's go ahead and kind of box that, highlight that, whatever you need to do, and let's kind of focus on number 1. So number 1 gives you that we're focusing on an angle pi over 6, and if you remember from the unit circle as we talked about last week, pi over 6 is exactly 30 degrees. So if I just kind of eyeball it a little bit, if this is my angle, theta, we're focusing on this arc right here. And we're going to go ahead and call that S. And as we're told, our radius is now 4. So we're going to go ahead and mark that. All I have to do now is take my formula. So arc length will be our angle in radians times radius. And so here we go. Our radius is already given to us in radians. Our theta is given to us in radians. So we're just going to go ahead and plug it in, pi over 6 times our radius, which is 4. And so we have 4 pi over 6, which is simplified to 2 pi over 3. So there we go. That's our arc length. Okay, number 2. So now we're working with 3 pi over 4. So as you remember from the unit circle, 3 pi over 4 is a pi over 4 family member, but it's not in the first quadrant, it's actually in the second. So it's going to be right over there. So here's our entire theta this time. So we're focusing on a larger arc length. So we're focusing on all of that. And that's going to be our S in this case. So here we go. If we follow our formula, S is going to be our radian, 3 pi over 4, times our radius, which is 3.5. And if we multiply that, we're going to end up with, let's see, let's go ahead and, because we're working with fractions here, let's go ahead and write that as 7 over 2, and so we'll have 21 pi over 8. All right, so there we go. That's our arc length. And number 3. So now, just be careful. We're working with a negative angle, and you know negative angles always go clockwise. So we're going to have to I'm just going to over-exaggerate a little bit so we can actually see this, but here's our arc, here's our radian, our angle, and we're focusing on this arc right over here. And so here we go, arc length will be our radian, negative pi over 12, times our radius, which is 10, which if we simplify will give us negative 5 pi over 6, but here's the problem. We can't have a length that's negative. So if you remember back from when you talked, about distances or lengths or anything of that sort, it doesn't make sense to have a negative distance or a negative length. So what we're going to do is we're going to kind of take the absolute value of that. And sorry, excuse that, y'all. So we're going to go ahead and actually just take the absolute value because our length cannot be negative. So write that down if you need to. All right, number 4, same thing. So now they've given you a unit, but that doesn't change anything at all. We're simply going to, again, go ahead and mark. And question for y'all, is that in radian form or do I need to transform that? So think about that for a second. So if you remember, that little r does actually stand for radian, so we're actually good to go. Remember, that's 0, here's 3.14, here's 1.57. So if I just look at those numbers itself, I know that 2.57 is going to be in the second quadrant, about there, let's say. There's my angle, and here's the length that I am trying to figure out. So here we go again. Arc length will be your radian times your radius, which is simply 257. Okay, number 5. What's the problem here on number 5? Take a look at your angle. Okay, the problem here is that our angle is not in radians, and so we are going to have to convert that. But if you remember from the unit circle, 60 degrees is pi over 3, so negative 60 will have to be negative pi over 3. So that was kind of easy. So there's that. Now we can just go ahead and plug it in. And it will be in the 4th quadrant going clockwise, and it would actually be a little bit outer. So here we go. So we have our radians, negative pi over 3 times our radius, which simply gives us negative 10 pi over 3. But again, what's the problem? Yeah, so the problem is the negative sign. So again, we're going to have to take the absolute value just about, and we're going to say that our arc length is actually positive 10 pi over 3. So there's that. All right, number 6, again, you have a degree. We're going to have to convert it. So if, in case you don't remember what exactly that is, that's okay. You can always find it doing your conversion, remember. So your degree times pi over 180 degrees, degree signs cancel. And once you simplify, you'll get 34 pi over 18. And we'll just kind of leave it, we'll just go ahead and, let's go ahead and simplify now that I think about it. Let's see. So that will give you 17. So 17 pi over 9. So now all I need to do is take arc length is my 17 pi over 9 times my radius, which gives me let's see, 17, 68. So 68 pi over 9. Okay, so now at the little middle section, very similar idea. So now you have radius and you have S, and remember S stands for arc length. So now it's kind of going backwards, and it's asking for you to find, it's asking you to find the radian. So we're looking for theta. Theta equals what? So we're just going to kind of tweak the little formula. So we have this so far, you multiply it by your radius. So let's just fill in what we have. We have 15 for S, we have 20 for your radius. We don't know theta. All we have to do is divide by 20 on both sides, and so we get theta equals 15 over 20, which is 3 over 4, and that is your radian. And we can go ahead and leave our answer that way. If we need to, though, however, ever change it to degrees, we can do that very simply, just like you normally would. Okay, number 8, very similar. S equals theta in radians times your radius. Let's go ahead and fill in what we have. So S we know is 6. Theta we don't know, but radius is 33 degrees. So go ahead and divide by 33 on both sides. And so I have theta equals 6 over 33, which we know is 2 over 11. And because it's in radians, I'm going to go ahead and keep it, and we're good to go. All right, so now the next section is going a little bit further. What we're looking at now is not the length so much. We're now looking at area, which changes a little bit. Yes, you do have another formula for this, but you might remember this one a little bit better. If we're talking about a circle and we're looking for area, let's say we're looking for an area of this section right here. And just so you know, sector is actually just part of a circle. If you were to define it, that's how you would define it. So if we're looking for area of just a part of a circle, what we're going to do is we're going to take the original formula for area of a circle, which is pi r squared, and we're simply going to just change it a little bit so that we're focusing on part of a whole circle, and multiply that now by your pi r squared. So now if I do an example, let's take a look. Actually, let's do number 2. So if I focus on this one, all I have to do here, I have r, I have theta, and so I'm just going to plug in what I have. So let's see. Here's my little section. So this is all I want to focus on. That is actually my part. So I'm going to say I want 2 pi over 3 out of my whole, and if you remember a unit circle, the whole is actually 2 pi. And multiply that now by pi r, which is 8 in this case, squared. And let's see, if I kind of work with this fraction, what ends up happening, and you can pause this video if you'd like and kind of work it out yourself, but what ends up happening is that the pi's cancel. And if we take a look at this, let's see, now we have 2 over 3 over 2, and I'm going to put that over 1 so we can see a little bit better. And let me take this over here. So we have 2 over 3 times, remember, reciprocate the bottom, so multiply by 1 over 2, the 2's end up canceling, and so you get 1 over 3, but remember you actually have all of this left. So pi times 8 squared, which is 64. And you can actually keep it that way, or what's even better is actually go ahead and if I gave you a calculator, you would be able to go ahead and tell me this with the actual unit. But we're going to go ahead and say that it's units squared, 73.89 units squared. Okay? And let me go back to number 1. So number 1, you have a degree. And so now let's see, same idea. So I'm going to take area equals part, which is only 120 degrees, out of my whole. Now remember, a unit circle is 360 degrees. So there's that bit. Now I want pi r squared. So let's see, if I simplify, my degree symbols go away. Really, I have 12 over 36, which is really just 1 over 3 times pi times 25. And if I multiply that all together and just kind of keep it in terms of pi, there we go. That's your area for that sector. Okay, if you look on the next page, on page 11, you have some application problems. We're going to skip number 2. We're just going to do number 1 for today. And we'll do the other examples in class. But if I were to look at this one, it tells you that Pittsburgh is located at 40.5 degrees. And actually, before I continue reading, I'm just going to make a quick picture. If I know that Pittsburgh is at 40.5 degrees, let's say that's about here, okay, on the unit circle. And it says Miami is located at about 25.5. So I'm going to say, and these are in degrees, so there's that. I'm going to say this is Miami, here's Pittsburgh. And it says, assuming the Earth is a perfect sphere, how many miles apart are the two cities? So what we're going to do is, first of all, we need to figure out what is the distance between them. We need to figure out what's the distance between them. So let's go ahead and do that. Let's say we have our, because we're in degrees, I'm going to go ahead and say this is in degree mode. And I'm going to say I want the difference. So 40.5 degrees minus our 25.5 degrees. If I go ahead and subtract those, I end up with 15 degrees. So 15 degrees is actually what I'm going to use to find out how many miles apart the two are. So I'm going to say, okay, I have these 15 degrees, but if you remember, we actually need radians. So I'm going to have to convert 15 degrees to radians, and it's going to be using the same conversion unit as normal. So we're going to say now we want in radians, so 15 degrees times pi over 180 degrees. So if you simplify, you end up getting pi over 12 exactly. So now I'm going to take pi over 12 and I'm going to put it into find arc length, because that is exactly what they're asking for. How many miles apart? What is the length? So let me go ahead and plug that in, and if you remember, the arc length formula is to take your theta in your angle in radians, which we just found, and multiply that by your radius. Okay, so now we're going to take pi over 12, and what's our radius? Yeah, so it's actually given to you. It's right over there. It's actually just 4,000 miles. So we're going to plug that in, and if you use a calculator, because this is a word problem, it makes more sense to use a calculator and get a decimal answer. So 1047.198 miles is what you get. So the two cities are actually that far apart in miles. Alright guys, we're going to go ahead and stop here, and we'll pick back up from here in class. And just always let me know whenever you have questions about this stuff, and we'll continue from here. Thanks for watching. Bye.